All right, for 12.7 day 2, we're going to step it up a little bit. We're going to solve a few more complex rational equations here. Here's the answers for day 1. Okay, let's get into the day 2 type problems. These are, we're going to have a fraction plus a fraction equals a fraction. And this cross product no longer works. And so if we take a look at this here, I'm going to box that there. You can get rid of all of the fractions by multiplying by the LCD. So the LCD of 3, LCD of 3, 6, and 4 is 12. And so if you multiply 12 by 2/3 x plus 12 times 1 over 6 equals 12 times 3 over 4, you're multiplying both sides by 12, and so what happens here is 12 divided by 3 is 4, so that becomes 8x. 12 divided by 6 is 2, so that becomes 2 times 1, which is 2. 12 divided by 4, and the third fraction is 3, so 3 times 3 is 9. You basically take an equation with fractions in it, and you get rid of all the fractions. So this is a really, really important technique. So what you do is you find the LCD. So the LCD of the 3 different fractions here, we have x minus 2 in common, and we have a 5. So it would be 5 times x minus 2. That's going to be the LCD. So what you're going to do is you're going to take your equation, and you're going to multiply it by 5 times x minus 2. And this is completely different than adding and subtracting rational expressions. And I actually like to put it over 1 so that I know that it's not over the same thing. Like when we added and subtracted, we multiplied that LCD on the top and the bottom, or that whatever number was missing from the LCD on the top and the bottom. This we're multiplying by the LCD. And so it is 100% different. So I like to multiply the top and the bottom, or the top by whatever the LCD is over 1. Now this looks really complicated and everything, but watch what happens. The x minus 2's reduce, and I'm left with 5x right here. The 5's reduce here, and I'm left with 1 times x minus 2, which is just x minus 2, equals, and then the x minus 2's reduce, and I'm left with 2 times 5 equals 10. So it starts by looking really complicated, but then it turns into something that is so easy to solve. So the initial step seems crazy, but then it just basically makes it really, really, really simple. Now, when I plug in 2 here, see that 2 minus 2 is 0. We can't have that. This one actually has no solution, which is interesting because all that work we just did, we did it for no solution, because when we plug in the number, it gives me 0 in the denominator in actually 2 spots. So there you go. That was kind of interesting. Let's give another one a go here. I'm going to put this over 1 to make it into a fraction. And then I'm going to factor this into x minus 7, x minus 2, so I can find the LCD. So the LCD is going to be, there's an x minus 7 in common, so I'm going to write that down once. I have a 1, but that's irrelevant, and then I have an x minus 2, so that's going to be my LCD there. So let's write this gigantic mess out. We're going to multiply by x minus 7, x minus 2. And when you're done with this process, if you have any fractions left, it means you've done something wrong. And I'm going to leave everything in factored form. So that I can eliminate things. Alright, so I took the LCD, multiplied it there, and I should have done this. I should have put my 1 over 1 there, I guess. And I multiplied it there, and I multiplied it there. There's my LCD, then multiplying to each term. Alright, now let's simplify here. So the x minus 7 is reduced there in that fraction. So we have 3 times x minus 2 is 3x minus 6. This one here, I have 1 times that. So that's going to be plus x squared minus 9x plus 14. And then the last one here, this is a fun one. Those reduce, and I have equals 8. So again, I took something that's really complicated, turned it into a linear or a quadratic equation. I have x squared, I have 3x and negative 9x, and that gives me negative 6. I have a negative 6 and a 14, so that gives me 8. Well, that's really nice because I have 8 on the other side, so those, when I subtract them, are gone. So I have x squared minus 6x equals 0 if I subtract the 8s. And then factor the GCF, which is x. More factoring at play, so x equals 0 and x equals 6. Let's check those answers to see, make sure that they work. 6 and 0. Okay, so if I plug in 6 here, that works. And 36 minus 54 plus 14, that does not give me 0, so that's okay. So 6 works, and then 0 also works. So this one has 2 solutions. And skip that. And I got a couple more questions here. I will pick one of them to do. I'm going to do a subtraction one right here for you guys. Factor this, n minus 11, and then n plus 6. So my LCD is going to be n minus 11, they share, so I only got to write that out once. A 1, I'm not going to write that, and then n plus 6. Okay, so let's write this gigantic equation out, n over n minus 11 times, I'm going to write down the LCD, n minus 11, n plus 6, divided by 1, minus 1 over 1 times my LCD, n minus 11, n plus 6 over 1, equals 22 over n minus 11, n plus 6, times my LCD, which is n minus 11, n plus 6 over 1. Okay, very repetitive process. And let's start reducing. N minus 11s are gone there, so we have n times n plus 6. That's n squared plus 6n. Minus, I'm going to put this in parentheses, I'll deal with this later. N squared minus 5n minus 66. If I multiply those two binomials together, which is just this right there, equals, and then n minus 11 is gone, n plus 6 is gone, equals 22. Okay, so now what I'm going to do is distribute that n squared, or the negative sign, to the n squared, the 5n, and the 66. And now we got an easy problem to solve. Those are gone, those eliminate. I have 11n, 6 and 5 is 11. Subtract the 66. Gives me negative 44, divide by 11, and negative 4 is my answer. Let's plug that in up here. Works there. How about over here? That would be 16 plus 20 minus 66. That doesn't equal 0, so we're good to go there. So negative 4 is the answer. And there is your assignment. Thank you guys for tuning in to the last day of 12.7.